Homework 10, quadratic functions, video number 1. In this section, in this chapter, we'll start analyzing different types of functions. The first function we're going to analyze is a quadratic function. Now, we've seen quadratic equations before, and we had several ways to solve them. That will be incorporated in our discussion about quadratic functions. But first, let's define what a quadratic function is and how they can look. A quadratic function is a polynomial function of degree 2. Polynomial meaning it's just the sum or difference of powers of x's, and degree 2 meaning that the highest power is x squared. There are two forms of quadratic functions, and personally, I think both of these names are kind of weak. One is called general form. It's a function of the form f of x equals ax squared plus bx plus c, which looks like the beginning of the setup for the quadratic formula, but it's not. It does match it though. There is the stipulation that the a is not equal to 0. Because if the first coefficient were 0, then this term would be gone, and now it wouldn't be quadratic anymore. It would be linear. The other form of a quadratic equation is called the standard form, which again, in my opinion, is an extremely weak name. If I invented math, I would rename this vertex form, and you'll see why later. But if you click help me solve this or view an example or read in the textbook, it will refer to this form as standard form. F of x equals a times a parentheses squared, and inside the parentheses is x minus a number, we're calling that number h, and on the end is a plus k. But these aren't the only forms that quadratic equations can come in, but they are the two most standard forms. I could throw something up there that's super junky and you can manipulate until it looked like one of these, and it would be quadratic. So for examples of quadratic functions, all you have to do is replace a, b, and c with numbers, or a, h, and k with numbers, and we have the same stipulation over here that the a is not equal to 0. For example, we could have f of x equals x squared minus, we'll say minus 7x plus 10. That would be a quadratic function in general form. Or we could have something like f of x equals, let's go with negative 3 open parentheses, x minus 1 close parentheses squared, and then a plus 7 at the end. That would be an example of a quadratic equation in standard form, or as I like to call it, vertex form. So what are we going to be doing with these things? Well, one thing we're going to be doing involves graphing them, and in order to graph them, we'll have to locate certain features. I think most of you know that a quadratic function's graph will be a parabola, so it will either open up or it will open down. So what features are we going to be looking for? Well, all parabolas have high and low points, but regardless of which direction the parabola opens, the higher low point, and more generically, the point where the graph changes directions vertically, it's going up then it's going down, or it's going down then it's going up. That point is called a vertex. Now these parabolas are going to be living on a coordinate plane with an x and a y axis, so we can also locate intercepts. This would have a y-intercept if it kept going. From the graph, we can extract domain, range, and answer other questions, but we will primarily be using the vertex and the intercepts to sketch the graph of a function, of a quadratic function. So you know we're going to be looking for, how do you find the vertex? As the name over here implies, that I changed it to the vertex is actually embedded in this one, but we'll talk about that in the next video.